Hello, everyone. Thank you very much for joining our editorial. I hope you're doing well. And let's wait for another couple of minutes and then we will start. Some more people are joining. Let's wait for another 1 or 2 minutes and then we will proceed. Thank you very much for joining today. The topic of our webinar is the editorial of last year's problem of Constructor Open Cup. Constructor Open Cup is our annual online programming competition, which will be also happening this year on February 12th. Okay, then I think we will start our webinar now. So first of all, again, thank you very much for joining us today. The topic of our meeting is the editorial on last year's problem of Constructor Open Cup. As I already mentioned, it's our annual online programming competition. And before that, let me introduce myself. My name is Demili, and I'm working at Constructor University. And before jumping into the main topic of our editorial, I would like to remind you and tell you a little bit more about bachelor's program in software, data, and technology at Constructor University and how it is connected with Constructor Open Cup. Bachelor's program in software, data, and technology was created by Constructor University and JetBrains Foundation. I hope you already know a little about Constructor University, but it's #1 private university in Germany. It's located in the northern part in a city called Bremen, and we focus on research-based studies and, of course, are looking forward to have the brightest and the talented students. We are also very international. We have more than 2,000 students from more than 100 countries. So if you get the chance to study with us, you will learn a lot about different cultures. And JetBrains Foundation, it's the part of the JetBrains group. I also hope that you heard about this big company. They create professional software development tools, and they have more than 11 million users worldwide. And I hope you all also know some tools and probably even using some tools. A couple of words about bachelor's program. So it's called Software, Data, and Technology, as I already said, and it's 3 years program on campus in Bremen. It has 3 educational tracks: software engineering, machine learning, and programming languages and tools. If you get the chance to study this program, you will have the opportunity to make your own research in one of these fields. But in general, yeah, this program is made for students interested in computer science and who want to excel in these fields. One of the great things about the program is the variety of different extracurricular activities that our students participate in. And it's not only events that are hosted by Constructor University, for example, like internship courses, incubators, and so on, but also international competitions, for example. This is the team of our SDT students from one of the programming competitions. Our students are always, several times, they go to such events and conferences as well. And yeah, this is one of the great things about our program. So how actually this program is connected with Constructor Open Cup? Constructor Open Cup is your chance to get fully funded scholarship for this program. So this fully funded scholarship is a unique feature of this program, and it covers tuition, room and board, even pocket money for the first year. This slide shows you the guidelines of on how to apply for this program and for this scholarship. So first of all, you have to apply on our application portal, which is apply.constructor.university. Then, of course, since it's the fully funded scholarship, there is a separate selection process for such scholarships and finding such students. That's why the first stage of such selection is to pass one of the competitions. And Constructor Open Cup is actually one of the competitions that allows you to go further in your selection. If you are the winner of Constructor Open Cup, you will be invited for the online interview. And if interview goes well, you are more than welcome to enroll to SDT program with this fully funded scholarship from JetBrains Foundation. Of course, this is only valid if you are eligible to study at Constructor University. If you don't pass one of the stages, so if you don't pass one of the competitions or if you don't pass the interview, you are more than welcome to enroll to the program with our regular financing offers. With this said, I just want to quickly remind the important dates about Constructor Open Cup. So it's February 2nd till 11th practice round to get familiar with the environment, to pass the test problems. And the main round, the main competition is happening on February 12th at 2 p.m. UTC, and it will be 4 hours online competition. So if you haven't registered, please go ahead and do so. And yeah, this is the QR code that you can scan. I think this was a small, hopefully short introduction to what it is and the unique features of it. And now I would like to introduce Valery, master students in advanced software technology at Constructor University, who will lead the main topic of our editorial, which is solution of last year's problems. So Valery, floor is yours.
Yeah, thank you, Emily. Hi, everyone. Yeah, let me introduce myself. So right now I'm a final year master student in advanced software technology. 2 years ago, I completed my bachelor program here in Bremen. All this time I had the opportunity to be an intern at JetBrains. I was intern there in 2 different teams. One of them was more focused on software engineering and another one was more purely research. So also I was a teaching assistant for one of the main courses on your program, which is JVM languages, and I was leading the tutorials and reviewing homeworks. And today, let's go to the main topic, is basically to do the editorial on last year problems. There were around 12 problems in last year. I don't know how many problems will be in this round, but I assume approximately the same. So the average number of tasks that people go to the interview was around 7. And in this editorial, I selected 3 most interesting tasks that focused on different ideas. And let's start with the first one, which will be the task F, which is already more than middle. So before I continue, I will shortly tell you that if you have any questions, you can ask them explicitly in the chat right now or after the task. It will be around like 1-2 minutes after each problem. We can discuss them in more detail if you have any questions. But the general structure of the task would be the following: that we will discuss the problem statement, what was the input, what was the constraints. After that, I will highlight the key solutions, key ideas that can help you to build the understanding of what we actually want to solve in the task. And with these ideas, you can already come up with actual solution. There will be no actual C++ code or Python code because I believe everyone writes in their own preferred language. And especially in 2026, I think any LLM can write better. But you need to focus on the idea and what was actually the solution. So let's start with the first task. And the description will be very simple. We have multiple test cases, and in each test case, we have an integer of positive numbers of size n. So this problem asks us to find the maximum sum of a good subarray of length k from 1 to n. So the first question, what is a good subarray in this task? Subarray considered is good if the following condition is met, which is basically that this subarray should be a non-decreasing array of continuous indexes. If there is no good subarray of length k, then return 0. So imagine we have an array of length 10. It means that we need to print the maximum sum of subarray of length 1, of length 2, of length 3, and so on. So that was the problem statement. And let's discuss the first question that comes to our mind is basically what subarrays we actually need to find. Because if we get, let's say, array of length 5, and we need to output for each k from 1 to 5, it would be too many different subarrays, and the time complexity will be too high. And if to be precise, it would be cubic times complexity n in power of 3. So let's just check the solution, how we would approach it in naive way. So in this case, the length of subarray will be equal to 1. And we're just going to iterate and collect all subarrays of length 1. And after we did that, let's say we store them in some different container. We're going to iterate over all arrays that we collect and calculate their sum. So in this case, the maximum sum is definitely 6. Well, after that, we print this sum to the answer and go to the next subarray of length 2. When it happens, we're going to do the same iteration, but right now we're going to collect all the subarrays of length 2. And in this problem, it will be 5, 6, 1, 2, and 2, 3. The same going to happen with when k equal to 3, but in this case, we have only one subarray. So we also going to calculate the sum of this subarray and print it to the answer. For k equal 4 and for k equal 5, we don't have any subarrays that follow the condition, which is tells us that it should be non-decreasing array. So what's the time complexity of such things? Since we're gonna iterate for all k from 1 to n, it will be linear time. And for each k, we're gonna take all indexes. So we're gonna take from index 0, from index 1, from index 2, and so on. It would be already quadratic time because we need to calculate and check if it's follow the condition or not. And because of that, it will take you the n in power of 3 time complexity. The n can be too large, and because of that, we couldn't get into the specific constraints such as 2 seconds. And because of that, we need to come up with a more optimized solution. So one of the things that we can check that, for example, if when we have the array of length 3, let me show you with pen. So as you can see, when we have the subarray of length 3, it also contains all different subarrays of length 2, such as array of 1, 2, and 2, 3, like this. And because of that, we understand that we don't need to iterate over all possible different subarrays. We only need to find the largest one, because the largest one will already contain the subarray with the maximum sum over all these subarrays, right? Because we know that all elements on position will be bigger than elements in the subarray, which is shifted by 1 to the left. Because of that, we understand that we only need to find the largest possible continuous subarray which follow the condition. And when we have different lengths such as k equal to 1, k equal to 2, we're all gonna check only this suffix sum, and it will be definitely the answer. So let's check how it will look like on the bigger array. For example, we have an array of length 10, and we have different continuous subarrays. So how are we gonna do that in this case? We try to iterate over the array until it's follow the condition, and when it stops, we gonna remember the position of the beginning of this array and the end position of such array. We stop on the element 20 because the following element after 20 is 19, and 19 break the condition because every next element should be not smaller than the previous one. Because of that, what we're gonna do? As I said before, we know that this is a continuous subarray, so each next element definitely is not smaller than the previous one. So we're gonna start iterating backward, and we can iterate backward in a naive way, just creating a cycle from 1 to size of this array, and we're gonna update our answer array where we contain the answers for k from 1 to size of the original container. So we're gonna start iterating from backwards. So starting from 20, we know that the 20 will be bigger than the element that we currently have in the answer. So we're gonna update it. After that, we continue iterate over such array and sum it with the next element. We can do that in 2 ways. Basically, we can either iterate it or we can recalculate it using prefix sum. I hope everyone is familiar with such technique, which is basically creating additional array which stores all the prefix until such element. And then you can just subtract from the current index and the beginning index. But let's do that in a way so it would be easy to follow. After we iterating to the next element, we're gonna update the answer in our answer array and sum it up with the next element and with the next element. So we process the first largest continuous subarray and we go forward. So the beginning position is 19 and the end position will be also 19 because unfortunately here we have a subarray only of length 1, but we still need to process it, right? Because the element in this position can be much larger than we currently have. So we try to compare it to what we currently have for k equal to 1 and check, is it bigger than we have? And if yes, we're gonna update it. So we check 19 with the current element, see that it's not greater than that. So we continue to processing the following subarray, which is 18 right now. We do follow the same operation. We try to compare with the current answer. If it's great, we're going to update it. Since it's smaller, we continue to iterating. So we're going to check. We take the 11. After that, we see that the next element is bigger than the previous element. We see that the 13 is bigger than the 12. That's why we have the largest possible continuous subarray from this position. So we're going to start to do the same operation that we did on the first subarray, and it means we start iterating backward from the first element till the last element, right? So we're going to compare it with the first element. 20 is still bigger, but the subarray of length 2 will be equal to 25 here, and 25 is bigger than 24, and that's why we're going to update it. And the following condition met for the subarray of length 3, 36 will be bigger than what we have before, what is 27. As you can see, we leave the last element equal to 0 because this is what was asked in the task. If we don't have subarray of lengths, specific lengths, we just return 0. So after that, we have our answer array. We're going to iterate it and just print all the answers. So the total asymptotic for such problem will be linear space complexity because we store and create additional array to store the answers. And also the time complexity for this problem will also be linear because we process our array only one time, and to process all the different largest possible continuous subarrays will be also linear from the size of these elements. That's why the time complexity will be linear. And linear is perfectly fine for such problem because n can be, largest n can be 10 power of 5, which is like under 2 seconds. So this was the first task, which takes us only one processing of the array and then calculating what is the largest continuous subarray, and then we just update the answers. If you have any question, you can ask it in the chat or in the QA section. I'm going to give it 1 minute. And yeah, also any feedback would be appreciated. If it's too quick, if it's too slow, if it's just right, let me know. It would be helpful to discuss the next problem, which will be the problem G. And we will discuss the 2G problem. Let's wait a minute to take a small breath between the tasks. Okay, I believe we can continue to the next task. The task G. So what we have here, let's look at the problem statement. So imagine we have like an infinite 2D grid. Also, we have a robot which starts in the beginning of the grid in the position 0, 0, and robot can move one cell per step in all 4 directions, such as he can move to the up, to the right, down, and left. We're given a string S consisting only of the following characters, which corresponding to the step he can move up, right, down, and left. So the length that of the string that we're given is always even, and this is quite important condition that we should use during the problem solving. So this string describes the route of the robot. Let's take a look how the robot what's the correct string? So a string called correct if there exists some cell xy such have the following condition. So imagine robot starts at position 0, 0 in the beginning of the grid. After that, it reach some point which we not specified, so it can reach any point xy. It can reach some point xy using some shortest path of length n. Then it should return back from this point to the start of his road using some another shortest path. It can use the same one, it doesn't matter. But the thing is that it should be also the shortest path and the length should be also equal to n. So the given string s that we have given describes these both paths concatenated. What's the problem with what we ask to find? So we need to find the minimum number of changes needed to make the string correct. In one operation, we can change any character to any other character, but we just need to do that in minimum possible number of ways. So again, we start at some position 0, 0. Then we given a string of length, let's say 2n. So it's even string. In n steps, we should reach some point xy. It doesn't matter what point it is. We just reach it in n steps using some shortest path. And then we should return back to the original position. And then we need to add this string called correct. So let's take a look what the shortest path even mean on 2D grid. So when we start from position like 0, 0 to some xy, the shortest path only if every step that we do is moving us forward to this position. So it means that we don't have any canceling moves, such for example, we go to the right, then we go at some point to the left. It doesn't need to be like right away after the step we make. It can be at any possible time because any moves like right and left, up and down, they cancel each other because we going one step backward. And also, it means that each direction, such as horizontal or vertical, is used at most one way per axis. So we just decide which way we're going. It's either we always going to the up, either we always going to the down, and the same thing happens with the horizontal lines. Then it will be the shortest path. So what will be the structure of our correct route? If we have the string, which is size of 2n, it means that in first half, which is length of n, we will gonna move from our position, the beginning of the grid, to some cell xy, and we will use only one horizontal direction. It will be either right or either left, and one vertical direction, either up, either down. And the second half will be also the length n, and it will be the way backward. So we're going to return back to the position 0, 0, but we're going to use the same number of horizontal moves in the opposite direction and the same number of vertical moves in the opposite direction. The most important thing here that we use the same number of horizontal moves in both ways, but in the second part, we use the opposite direction. So if in the beginning we were always moving to the right, let's say 5 times, it means that we should use 5 times to the left in the second half of the direction. So these two key observations help us to understand that we should leave the representation of the string of the moves rather than just counting how many times we go in some specific direction. And before I go going forward, I would love to ask to the question that, yes, this recording will be available after it finishes, and it's going to send to, I guess, every student who is registered for Open Cup, which will be in 3 weeks. So let's going forward. For example, to visualize the problem, because I believe every problem that requires any work with the tree, so like on the 2D grid, is always better to visualize. So imagine we were giving a string, the following string. So what we're gonna do, we split it in two halves. The first half is displayed as a black color. So we're going to the right, up and right, and we reach some point on the grid, 2, 1. And the second half, we're going down, left, and down. So obviously, this is not a correct string, right? Because I will repeat that the condition to be a correct string is we should start from 0, 0. We should reach some point using the shortest possible path. This condition is met because to reach point 2 plus 2, 1 will require exactly 3 steps. And unfortunately, it doesn't follow the second condition that we should return back to the original position because we return to the position 1 minus 1, which is not exactly what we want. So we need to fix this road by changing some step to another one. So one of the possible way, which is clear, is to change the last step from down to left. And it will be, the route will become like this. So right now it becomes the correct string because we use both time the shortest path to reach some cell and to go backward. And we did exactly one change. It's like the minimum number of iterations we can do, right? We did it from changing the last step from down to left. But you could also change, for example, in other way. For example, you could change it by replacing the first letter with the going to the left. So it could be down, it could be left, left, and down. And it will be also the correct way because it's also the shortest path. But right now, instead of changing the last letter, the last step, you change the first one. So it gives you a bit of more uncertainty which way we should change, or should we even care about that? Or we just need to change it somehow to make it the shortest path and to make it backward. So also, another way to think about this, that we don't need to always change only the second part, because the original, the first half, is not set, right? Because there is no fixed point to which we should end up. We just need some point at position x, y, but we don't know which exactly. So we can change any step in the first part as well. So if the original part was like right, up, right, we could change the last step to the right to change it to the one more step to the up. And then you have the string right, up, up. And then the second half is exactly correct because it's exactly the shortest path to get from position 1, 2 to position 0, 0. So this thing gives you the understanding that we don't know exactly what letters to change because it could be possible ways, and to find exactly one of the possible way would be much harder rather than to count how many operations we need to do. So what we observe during these three examples. One thing that is important, that the same string can be fixed in multiple different ways, all using the same number of changes. We just show like 3 different ways to fix the example before, all using only one operation. Because of that, we don't know what characters we should change, but we could know how many moves of each direction is required and how many of them is already requisite. So exact orders of moves doesn't matter. We only need to think about what's the number of moves we actually need in some specific direction. So let's take a look at the solution. Yeah, let's take a look at the solution. And before that, yes. So what we're gonna do? We're gonna split the string that we're given into halves of length n. After that, we want to count the occurrences of each character in each half. We can do that just creating the hash map, storing the character and the amount of time it appears in both halves of the string. After that, we just try to iterate over all possible number of horizontal moves. So we know that the length of the first path is n, so it can possibly contain all horizontal moves. So it will be n horizontal moves and 0 vertical moves, because if you know how many horizontal moves, you know exactly how many vertical moves will be. It will be n minus horizontal moves. So if you know one of them, you already can derive how many vertical moves will be. So you're gonna iterate over all of them. And after that, when you have already fixed numbers of A and B, you just need to compute how many characters can stay unchanged. So how many characters are already correct in such terms that we don't need to change them. So let's go to the details of such function. So we're given fixed values A and B. A is how many horizontal direction, and B how many moves in the vertical direction. So first half, we want all A moves will be in the same direction. It will be either right, either left. Then second half wants exactly A moves, but in opposite direction. So if in the first half we were always going to the right, in the second half, we always want to go to the left, and vice versa. For the vertical moves, which we can derive from how many horizontal moves we had, we also want to have only go to the up or to or down. And in the second half, it would be the same number of moves, but in the opposite direction. So let's say how we can like iterate over all possible directions. We can just create the array over all possible combination, such as right and up in the first half, right and down in the first half, only right, only up, only down, and so on. So you just create like a loop over these two different directions. And after that, you just need to compute how many of them are already exist. So for example, we want to have like, let's say 5, we iterate from 0 to n, right? To iterate over all possible scenarios. And we need to understand how many of the characters are already exist. To do that, we have like two helper functions, which is we already pre-calculated. So let's say we know that for this iteration, we need like 5 appearances of the right, and we also know how many occurrences of, let's say, move error were already in the first part of the string. And also, you know how many of them was like in the second part of the string, but you have like the helper function, let's say opposite, which can give you the opposite direction of the current one you have. And with such things, you can understand what was the total unchanged characters in this string. And it will be just like the sum over all 4 different directions. So it will be the direction of in the first half, the opposite direction in the second half, and the same thing with the vertical lines. After that, you just take the maximum amount that you calculated, and the result will be the total length of your string minus the characters that you don't need to change. And it will be the answer to the minimum number of operations you need to do. So this is the solution of the second problem. So if you have any questions, you can ask it right now. And before that, I will give you again the overview of the solution. So we have a string of size to n. We want to split it into halves. We will count the occurrences of each character in both halves of the string. After that, we'll just try to iterate over all possible scenarios, how many horizontal lines and vertical lines we want. And for each scenario, we'll just try to iterate over all possible directions, such as right and up, right and down, left and up, left and down. And we will just try to find what was the maximum amount of characters we can kept using the required characters. And after that, we just take the maximum of them. This will be the answer for the second problem. So we'll take a 1 minute break before going to the last task, which will be the task I think it's the 9th task out of 12. We have an interesting idea on the graph. Okay. Here I also have a Q&A. So already know, I mostly look in the chat. So in the region example, we are prohibited from going left, down, left, right? Let me quickly go to this example. In the region example, we are prohibited from going left, down, left. No, of course not. We're not prohibited. Obviously, so the question was asked 5 minutes ago is, can we go left, down, left? So obviously this is one of the possible options because it will be the correct string because it uses the shortest path from point 2 to 1 and it go backward to the beginning of the grid. But the problem is that the amount of changes you need to make is equal to 3. And we asked to find the minimum amount of changes we need to apply to such string. So this is possible the answer, but if we change only one letter, for example, from D to L, this will be the shortest way to make the string correct. Yes. That's why we try to get away from representing the string as some sequence of letters to just represent the string in phone numbers. And this phone numbers is just how many times each character appear. Yes. So that's the question on this answer. Sorry for a bit delay. And I think Tuba, I think we can come back to your question after the third task because I think we a bit lost track of the first task already. So yeah, if you have a question, can you ask it one more time in QA a bit more explicitly, and I would happy to answer. Thank you. Okay. Emil, is it necessary to write in a detailed depth? Can you clarify the question? To write in detail. Yeah, let's wait 30 seconds before going forward. Okay, let's go forward to the next task. So this will be the final task for today editorial. It will be, okay, but there will be no spoilers. Let's just try to read the problem statement and understand and come up with some solution. So what we're given? We're given two numbers, number of students and number of projects. For each, then we're given m pair, and for each project from 1 to m, we're given two integers. We're given integer x and y. This is the students who was working on project I. There are two possible ways. If x equal to y, it means that the project was done by one student, and otherwise it was done by two students. Imagine we have like a conference and we want to select some amount of projects. So we can do that in the following way. When we like organizing the conference, we can select some projects, and each project can either be represented by X or by Y student. So two students cannot represent the same project on the conference. Only one of them can do that. Otherwise, we can exclude the project at all from the conference, and none of the students will attend it. So a student invited only and only if the student present at least one project. So the problem is for every top, let's say for every k from 1 to m, we need to count the number of different subsets of students that can be invited using only the first k projects. So imagine we have like 10 projects. We need to understand how many different subsets of students we can invite for one project, then for the first two projects, for the first three projects, and so on and so on. And we need to give the answer for every key. So let's going forward and to see the example. So imagine we have like 5 students, because we were given the amount of students we have. And from the problem statement, we can understand that each project mentions either one student or two students who was working on it. And choosing this project, let us pick one of these students. So what possible scenarios we can have? Imagine we have like the first project that appears, and we're given like a pair of 3, 3. It means that only one student was working on it. So project 1 was done only by one student. So we represent it like this, like a cycle. Then the second project appears, and it was done by student 1 and student 2. So how many possible ways we can select? Imagine we have like one slide above, and we have like only one project, right? And we were asked to give the answer for every key. So right now we have like one project, and what are the possible way to select the students for the conference? So we can either select the student to present this project, either we can exclude the project at all. So there are two possible ways to do that. it either project 1 is included in the conference and student 3 will present it. Otherwise, project 2 is excluded and no one will present it. So there are two possible ways. Okay, we will remember this number. And right now, let's going forward. And the second project appears. And as you can see, project 2 doesn't relate to student 3 at all. So it's completely two different students that was working on it. And if we will take a look only on this project 2, how many students we can invite from this? We can either invite student 1 to present it, either we can invite student 2 to present it, either we can not include project 3 at all, project 2 at all for the conference. So there are three possible ways. So since we now need to give the answer for the first two projects, we need to combine the result with the previous one. So in this case, we'll just multiply the answers, right? Because no matter what, who we choose for the project 2, we still have two options with the project 1. We can either invite student 3 or we can exclude it all. So since these two events are independent, we know this rule that since the project is independent, we're gonna multiply them. So there are 6 possible ways to invite students for the first two projects. Then the same thing happened. We have like the third project, which was done by student 4 and student 5. It's the same situation here as student 1 and student 2. So also 3 possible ways to invite them. And we're going to multiply with the previous one because they're all independent. And the project 4 appears, and this is the most interesting one because you can see this as like some specific component, component with project 2 and component with project 3. And then the new project unite both of them. So now we have like a single big component because now we combine student 2 and student 3 because they united by project 4. So in this case, we need to understand how we can calculate the answer for the first three projects, because now we cannot multiply it with the previous answer that we had because it kind of affects both of these components. But if we take a look, we can see that the structure of these two different components are kind of the same. Here we have like two vertices and one edge, and here we have also like two vertices and one edge. And in the new merge component, we have 4 vertices and 3 edges, and it's follow the same pattern that all of them is a tree, because we have like the tree is a graph where where the number of vertices is bigger than amount of edges exactly by 1. So let's take a look at these two different cases and understand how many possible scenarios we can actually select from these two structures. So let's say the case 1, we have component is a tree. So amount of edges is equal amount of vertices minus 1. In this scenario, each project can invite only one student, right? Because we were told that 2 students cannot represent the same project on the conference. So project 1 can invite either student 1 or student 2, and the same thing happened for project 2. Can we invite all these students? For example, can we invite all of them? Can we invite S1, S2, and S3? To do that, we need more than, or at least the same amount of projects as amount of students. But since we have a tree, we have only v minus 1 project. So we can select any subset except the full set. So we can only create twin power of number of vertices minus 1. Now we have like a simple proof why we cannot create the subset including every student. So to do that, let's select some vertices as a root. For example, it will be student number 2 will be like a root of our tree. And to do that, we will redirect the edges. Edges will be a project, so we redirect it toward the student that is selected. So project 1 will select student 1, as you can see, and project 2 will select the student 3. So we select every student except the root 1. So any other possible subset of them can also be constructed if you like skip some edges. Also, we can do that with any edge if we select it as a root in a tree, and we will redirect all edges from it. So in this case, we'll select student 2 and student 3, and the same thing happens if you select student 3 as a root. So you can select the first 2 students. So why the amount of different subsets is 2 in power of v minus 1? Well, the answer is like this because, as we just proved, that we cannot select every student on that because we need at least one more project to do that. And the answer is 2 in power of v because each student can be either selected, either not. So we have 2 possible outcomes for every student. And if you have 2 possible outcomes for every student, because all of these are independent, you'll just multiply it. And if you multiply 2 options for each student, it will be exactly 2 in power of amount of vertices you have. So we just understand how many vertices we have for a tree. Now let's understand what we have when we have a cycle. So cycle is a graph when we have amount of edges at least equal to amount of vertices. So when we have a cycle will give us enough freedom to choose any presenters. And because of that, any subset of the student can be invited. So why do we need at least one cycle? Because in the cycle, we can redirect the edges in some way that every student will be activated. So because we know that, let's say, degree of amount of edges going to student 1 is equal to 2, so you can redirect it the following way. For example, student 1, so the project 1 will activate student 2. Because student 2 is already activated, project 2 will activate student 3. And because project 3, the student 3 is already activated, project 3 will activate the student 1. So we need at least one cycle in the way to be able to redirect the edges in such way that every other student will be activated. For example, let's say if we have like additional component, let's say of students, doesn't matter what student they are, we still can redirect it such way that, for example, this project will activate the later student, the middle project will activate the student, and let's say, project 4 will activate the student. So in this way, we can see that every student is activated because we redirect the graphs in such way that every is included. So we have 2 in power of number of students, because for each student we can either select him, either not. And if this is the case, then the amount of possible outcomes is 2 in power of v. So right now we just understand how many students will be able to select if we have a cycle. So what's the key idea? The idea is that we're gonna maintain a graph. To be more precisely, we'll maintain connected components using this join set union. It's a data structure that allow you to easily unite 2 different sets of elements, and that's exactly why we need it. So vertices will be the students and edges will be the projects. So we realize that different components are independent, and if they're independent, the answer is just the product of all answers of all these components. And we also just prove what's the contribution of some components when we know how many vertices and how many edges it contains. So it will be 2 in power of vertices if it's a cycle, and 2 in power of e minus 1 if it's a tree. So we know how many possible outcomes we have for each component, depending on the structure. We understand how to calculate the total answer, and also we know how to maintain these kind of connected components. So now let's check how we're gonna store number and how we're gonna what we're gonna do when we have like a new project appears. So which component in design sets union we're gonna store a number of vertices and number of edges. So basically we have like a single array. We have two different arrays for storing number of vertices for specific component and number of edges. After that, we will maintain the global answer. It will be the product of all components. Don't be afraid of this modular division by this big number. It was told in the problem statement because how you can imagine, when you need to calculate all possible outcomes of different subsets, the number can overflow the integer and even the long. So to prevent that, we will just divide it by this modulo, which was given by the problem statement. So when we're adding a new project, let's say this is a pair of XY, we're going to find in what component all of the students are currently in. So when we originally initialize the DSU, we just iterate over all students and assign them their own components. So we have, let's say, 20 students. It means that we have 20 different connected components, right? Because each of them is a separate one. So we have two different scenarios. If these vertices inside one component, it means that we add additional edge, and this edge is probably create a cycle. So what we need to do is we need to remove all contribution of this component to our global answer. And we will, after that, increase amount of edges by 1. Since we know how many each component contribute based on the amount of edges and vertices, we can calculate the new contribution and add this contribution to the total answer. Basically, the first step is very important to remove the old contribution. Otherwise, you will have double calculation of the same amount of vertices. So you first clean what the current affected component contribute to the answer. You remove it. After you remove it, you update it with the new value. So the second answer, with me before the question. Okay. The second case is when we merge two different components. This is exactly what happened on the example when we have two different components, and then we have a new project that connects these two components. So when it happens, we first also need to clean the old contribution to the global answer from these both components. After that, we're gonna merge them in DSUM. When we merge them, we basically just rewrite what's the connected component the current vertices belongs to, and we need to also to update the how many vertices and how many edges the new merge component have. Basically, the amount of vertices will be the same. It's just sum of these two companies that we're trying to merge, and the amount of edges will be also the sum of the edges we currently have plus 1 because of the new product that we just add. And after that, we calculate the new V and new amount of edges, And if we knew the new values of them, we can again calculate what's the actual contribution of this new merged component to the global answer. And to do that, we just calculate this value and we multiply by the answer. And this will be the final result. So this is, this is the end of this task. So the main idea was here to try to visualize it and understand that the original problem is constructed as a graph problem, and you just need to understand how what's the contribution of each component. Sometimes I think in contests like this, you have like some idea or theory, like for example, which will prove that for a component with such amount of vertices and edges, its contribution is the following. Sometimes there will be like probably scenarios when you can actually prove it, but you always can just to try to implement it and see will it pass or not. I usually, not usually, but sometimes I did that. So yeah, that's the latest stack, which was on graphs. So today we make overview of three problems, made overview of three problems. One of them was like more technical one when you just need to implement it. The second one, you need to find some pattern and derive the problem from a bigger presentation to like just a smaller version of it. Was the robot bus, and in the third problem, you also need to convert the problem from the statement to some computer science statements such as graph problem and disjoint union. So I'll wait a couple more minutes. More questions? I'm happy that we have the same amount of people that joined in the beginning. I think it's a success. And while waiting, you can ask any questions, not only related to the editorial, but I guess to any other questions you have, and Emily will answer all of them.
Yes, thank you very much for this nice editorial. And while you're thinking about the questions that you might have, I just want to quickly show you the useful links that you can visit. So, of course, first of all, it's the webpage of our software data and technology program. We also have Telegram chat. We post different announcements there and different useful materials. Please make sure to join it. And in case you have specific questions, please also use our contact email, which is talent@constructor.university. And about the useful links. So again, if you haven't yet, joined the Constructor Open Cup, please make sure to sign up. The main round will be happening on February 12th. As I mentioned, there will be also practice round where you will be able to try the environment. We also have a big, nice video where we explaining more about software data and technology program at Constructor University. So if you are interested in learning more about it, please watch our webinar. And also we have a QR code to where we have some tips on how to prepare for programming contests. So please feel free to make the screenshots of these links and check them out later. So there's some questions in the chat. How much time would the competition last? 4 hours, that's correct. So the main round is on February 12th. It will start at 2 p.m. UTC time. So please make sure to double check with your time zone. And we are planned this 4 hours for the competition. Nice editorial, thanks. Is there any way to get access to some online judge with previous year's problems to kind of try to write code to other tasks and test it, for example, on code forces? It's a good question. There is, everything was organized on code forces and Constructor Open Cup 2025 as well. You can try to find it there in the list of the events, and if it's possible to write code there, to be honest, I'm not sure, but maybe you can check it yourself. Is there an anti-cheat system? Yes, so the submissions will be checked shortly after the end of the competition. Let's check also Q&A. I think Q&A was answered by Valerie, right? So I think all good.
Yeah, I answered some questions in QA.
Is the paper cheatings accepted? It's all online, so you don't need any paper for that. Yeah, you just submit the solution and then it will be tested by the system. For that, I also highly recommend to join practice round. So it will open from February 2nd, and you will be able to test the environment. There will be also sample problems that you can also solve as a preparation as well. And you will see how the system works and what to expect on February 12th. So please don't miss the opening of the practice round. Thank you for your question. So I think your last chance to ask questions about the program, about the editorial while we are all here. Let's wait for maybe another 1-2 minutes. Q&A is empty so far. Any questions you want to post in the chat? So I think so far there are no more questions.
I think so.
What programming language are we going to use during the competition? So the platform which will be hosting the competition is Codeforces. I hope that some of you are familiar with that. Yeah, thank you very much. I think you sent the link to hosts and panelists. Maybe you can resend it to everyone.
Oh, yep. Sure.
So Valerie will send the link of the platform where everything will be hosted. And this platform accepts a big list of different programming languages. So most probably the one that you know is in this list, and you will be able to write all the solutions in the language that you're familiar with.
Yeah, there is no strict requirement to use like any specific language. I think most people use C++ or any other compiled language because it's a bit faster. But I think for the, I don't know, first half problems, you don't need such speed. For example, you can use any language you want.
And if there are no more questions, I will send the link to our webpage one more time. So let me put it in the chat. We will publish this, the recording of this editorial there, as well as the email will be sent out to all registered participants. So you can check out the editorial one more time. Plus, if you already have been registered for Constructor Open Cup, we will also include the link to the editorial of Constructor Open Cup of 2024. So you will have the chance to check out 2 editorials. I think then, thank you very much for joining our session today. And we wish you all the best of luck at the Constructor Open Cup 2026 and really hope to see you there and probably on campus at Constructor University. Thank you.
Thank you, everyone.
Bye-bye.